Texan Global School. Differentiation formulas. In this class, we analyze the concept of derivative and the rules to derive functions. As demonstrated in the previous class, the derivative of a function f with respect to x, denoted as f prime of x, is the limit as h tends to 0 of f of x plus h minus f of x over h. Again, we show the different notations that represent the derivative. From this definition, we will prove the rules. Let's see the first proof. To obtain the rule to derive a constant function c, whose function is a horizontal line y equal to c, where c is a real number or a constant. As it is a horizontal line, its slope is 0. Therefore, its derivative must be 0 as well. We will use the definition of the derivative to verify. We define each function, in this case both are c. By substituting and simplifying, results the limit as h tends to 0 of 0, which results in 0. Therefore, the derivative with respect to x of a constant c is equal to 0. Let's see another proof. To obtain the rule to derive a function f of x equal to x, whose function is a straight line y equal to x, let us use the definition of derivative. So let's define each function, in this case f of x equal to x, and f of x plus h equal to x plus h. By substituting and simplifying, results the limit as h tends to 0 of h over h, which is 1. Therefore, the derivative with respect to x of x is equal to 1. In this way, the demonstrations of the rules to derive that are presented on the board can be performed. The power rule indicates that the derivative of a function f of x equal to x to the n power is equal to n times x to the n power minus 1. The constant multiple rule states that the derivative of a constant c times a function f is the constant c times the derivative of the function f. The derivative of a sum or difference of functions is the sum or difference of the derivatives. It is called the sum or difference rule. The product rule states that the derivative of a product of functions is the first function times the derivative of the second, plus the second function times the derivative of the first. The quotient rule states that the derivative of a quotient is the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator divided by the square of the denominator. Finally, the derivative of an exponential function e to the x is exactly the same. The same rules are shown, only presented with a more simplified notation. Let's see a first example. Derive the function f defined as f of x equals 5x cubed. Using the rules of differentiation, we can use the constant multiple rule, since it is the product of a constant and a function. We can see that the constant c equals 5 and the function f equals x cubed. Substitute, resulting 5 times the derivative of the function x cubed. Now, derive the function x cubed using the power rule, where n equals 3. By substituting results 5, which is the constant c, times 3 times x to the third minus 1. So the derivative of the function f of x equals 5x cubed equals 15 times x squared. Essentially, any function of this type is derived by multiplying the exponent by the numerical coefficient and subtracting 1 unit from the exponent. As an additional exercise, it is suggested to derive using the product rule. You can see that the same derivative is obtained. Let's look at another example. Let us find the derivative of the function f of x equal to 2x cubic minus 5x. Using the rules of differentiation, first use the rule of the sum or difference. Essentially, apply the derivative to each term. Now, use the rule of the constant multiple in each term. Then, let's take the constant and multiply it by the derivative of the function, which with the power rule can be derived. The derivative of x cubic is 3 times x to the 3 minus 1, and the derivative of x is 1. By performing the products, results the derivative of the function. Therefore, the derivative of 2x cubic minus 5x is 6x squared minus 5. In this other example, we will derive the function x fourth times e to the x. Since it's a product of functions, derive using the product rule. So let's multiply the first function by the derivative of the second, plus the second by the derivative of the first. Now derive the pending functions. For the first, the derivative of e to the x is exactly the same, and the derivative of x fourth using the power rule is 4x cubed. In this last example, derive e to the x over x. Since it is a quotient of functions, use the quotient rule shown on the board. So it is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by the denominator squared. We then derive the pending functions, thus obtaining x times e to the x minus e to the x over x squared.
Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com